Johannes, now we are at one of our pilot project bikes and scooters, and we have had the pleasure to have an Interreg project together with the city of Arnhem, the company eFlow, Unicorn, and some others, even Ireland and UK and France and Luxembourg and from Netherlands, many more players. And therefore, we have been able to fulfill the request of the European Union to showcase if the standard also works in reality. So we've been able to have some prototype applications like this eFlow sharing bike, which is now connected.
Yes.
And because the bikes have been we just added the chargeable cable later, the authentication is happening in the plug.
Yes.
So I can't unplug it without key. But do you have a key?
Yes. Yes. But first I showed how it is connected. So we bring the plug and the cable to this position between battery and motor controller. There we put our cables to the rest of the cables inside the bike, and there we read out, for example, the CAN bus. We read out the signals that the battery thinking there's a charger. So this will all simulated in the plugs. So that's why we integrated in the plug a lot of electronics in the moment to be possible adapted to this old style stuff. I hope in the future this interface will be much easier to implement it if the manufacturer says clearly, oh, that's our interface for the future, connecting directly to this plug. This plug has also a near-field communication reader. I have here in my pocket always the channel key. So I am able with this channel key, for example, open all kinds of vehicles here in the exhibition. I bring it nearly the connector, and then the connector says to the charging station, please open, and the charging station open. This socket is also very special for this project. It is an IoT socket in this moment. So we built in a mobile phone there in each different socket that we can collect all the data to a server and make there a lot of measurement, especially the odometer of the vehicle, that we know how many the people are riding, and all the power consumption. The power consumption in the plug, in the socket, in the power supply. Everywhere we're collecting data, we bring it out to the cloud. Inside, behind this connector, inside there is a AC-DC converter built from the company Delta Q. There is, for this project, we're using a 350 watt charger with a communication protocol. This was the only company we find who has a charger in this dimension with CAN open. So it was easy to integrate the CAN communication. But in the future, I hope, and with the standardization, it will be possible that each of these chargers speaks the same language, each of the bikes speaks the same language. Then the integration is much easier than today, where everyone do a different communication.
Yeah, and also important is, even this is a housing, is that the charger, the AC-DC converter is waterproof.
Yes.
Which in this case of Delta Q is absolutely no problem, because these devices are made for onboard chargers in motorcycles as one of the original applications. And the good thing is the station also works for like the scooters. This is the scooter from eFlow, very fancy, sturdy scooter. And also here we have the chargeable cable integrated. We also used for the scooter, because it's a low voltage scooter, the 60 volt 60 amps. So far the 120 volt version is not implemented yet. So we're looking forward to have some manufacturers which will use this. And here you can see a stand-up scooter, even older prototype connector. So actually the connectors still have been 3D printed in this case. But now, some years later,
Yes.
it's in production. So the samples which you have seen earlier are manufactured by an Indian member of EnergyBus, the company eZpedal, and based on the unicorn technology. We will have a look on these ones.
Yes.
We just move.